the radian measurement is the most commonly used type of measurement for trigonometric functions in them on the mathematics side, more so than angles, due to the fact that it's unionless and that it's more of a normal transition. Whereas we use degrees a lot when we deal with triangles, but when we're dealing with equations and graphs and all those things, usually we want to be using radians. So you'll hear me say this in future videos. We usually want to use radians. But there are some contexts where we want to use degrees instead. But like everything we've been doing so far has all been in what we call radians. Like looking at this, uh, it's been using radians. So what does that mean? And what would be the difference to say working with it? Let me go back to the slides because there are some um, definitions. But when we're talking about shifting to angles as opposed to terminal distance, um, the books often will define what does an angle mean. But like in the mathematics side, angles are defined to be created by two rays. Like if I have two things, two lines, those lines create a particular angle. And that's one way that I could describe how big an angle is. It's not based on measurement, like measurement of length, but it's more of it's a different form of measurement, which is very unique to like a width. It's not even width, but anyways, um, in the sense of trigonometry, I want to describe how are angles defined in trigonometry because it's very similar to how we defined initial point, terminal point in videos. But basically, when we're defining angles in a trigonometry sense, we often refer to them as being in standard position. So with standard position, that always means that the initial side, basically the ray that creates it, as you can see in the slide, is always the positive x-axis. So it's kind of like how on the unit circle we always started at that point on the right-hand side, 1 comma 0. That was just defined to be the initial point. Well, the initial side of an angle is always just defined to be the horizon, the right x direction. And when we're describing an angular measurement from that location, we're always starting here and moving to the terminal side of the angle. So an angle is defined by two rays. The ray that we start with, the initial ray is always that way, and then it's defined by rotating that side a particular angle. But we could also take the initial side, rotate it clockwise, where counterclockwise is the positive direction as it was before for angles. So this angle could be, say, 30, 45 degrees, whatever. But we could also rotate it clockwise, which would give us a negative angle as well. Kind of like moving counterclockwise or clockwise along the circle. But essentially, there's a correspondence between a distance, the t values that we're associating with the unit circle, and separately, what is the corresponding angle. So they are the same thing, but the difference is between distance and angle. They're different forms of measurements. So an angle, when we describe what is radians, what is a radian measurement? A radian is an angle, but it's measured based on a distance measurement. So let's scroll to the next slide, which defines what uh, angle is, and let me erase all the ink on it. So let's read the definition of radian measure. It says, in a circle of radius 1, the measure of an angle in radians is the length of the arc that subtends the angle in that case. So that's just a fancy word for, like, like what I was saying before. Here's the angle. This is the arc that subtends the angle. And if we wanted to know, well, what is the radian measurement of this angle, it's going to be always defined to be the arc length of that particular part. And why this comes back to the unit circle is, well, the unit circle was always defined based on those distances t. Like, for example, let's say that this was the very first point on the unit circle defined by pi over 6, um, which would be this length. That would be, if we were describing the angle itself, that would be pi over 6 radians. So there is a difference between the length pi over 6 and radians. Pi over 6 refers to a length, but pi over 6 radians refers to the angle. And that's it, really. So what I'm getting at is everything we've been talking about has all been in radians. And every angle, corresponding angle within the unit circle, has been in radian mode. So when I'm evaluating sine of, say, pi over 2, pi. That's all been in radians, and we've been evaluating not only the correspondence based on the unit circle, but also the the relationship between angle. Now in degrees, uh, it's kind of nice because if we look at the definition of degree measurement, it says a complete rotation is defined to be 360 degrees. Since one full spin is 2 pi. Like going back to the unit circle, like if we were to go all the way around, most people are familiar with the idea of, well, if I do a full spin, that's 360 degrees, complete rotation. Um, and so if we're trying to connect the dots between radian and degrees, well, we know that a full spin on the unit circle is 2 pi. That was the circumference of the unit circle. So if 360 is also defined to be one spin, those two things must be equivalent because they're both the same amount. One full rotation is 2 pi radians. It's also 360 degrees by definition. Now, before we get into converting and stuff, it's all based on that basic understanding of equality between 2 pi radians and 360 degrees. Uh, I want to say, well, why 360 degrees? Kind of circling, like moving away from math for a second and getting back into the history side. I don't know if you've ever wondered why is 360 degrees rotation? What is that? Why it's kind of an arbitrary number. Well, it's not really arbitrary. That's the point I'm trying to get at. But or like why is 180 degrees turning around? Actually, there's a very famous quote from, maybe not famous, but there's a funny quote from a former basketball coach, or he was a former basketball player. When he started coaching, he was quoted to say, I'm going to take this team, which was very bad at the time, and I'm going to turn them completely around 360 degrees. So what was kind of funny about that quote is if you turn all the way around 360 degrees, really you're going in the same direction because you've done one full spin. You haven't actually really changed your direction. What he probably meant to say was, I'm going to take the team, turn it around 180 degrees, which would imply that you're going the reverse direction um, instead of a full circle. But I digress. That's just a comment. But basically, circling back to the fundamental definition, 360 degrees is equal to 2 pi radians. And also, that's an equivalence relationship, which in math, we can actually use that to determine a direct link between radians and degrees. So if we were to take that equation and divide both sides by 2, what we get is, well, 360 cut in half is 180, which is a half turn, which is equal to pi radians. And kind of when we were talking about going halfway around the circle, that was pi radians. Well, that's 180 degrees. That's why 180 degrees round. And also, if we were to take this relationship and divide both sides by 180, what we'd isolate is, well, how much is 1 degree? What does 1 degree mean in radians? And if you're really familiar with degrees, we know that 45 degrees is like the exactly, halfway slant between perpendicular and parallel. But if you think about 45 degrees, if we were imagining 1 degree, 1 degree is a very, very slender, very, very small angle. So if I'm trying to understand that, it's kind of hard to visualize what that means, but this is a key direct relationship between what is a degree and how does that transition to radian. But and also in the same way, if I started with this same equation and divided instead by pi, I could isolate, well, what does 1 radian mean? If I'm talking about what's 1 radian, what's 2 radians, what does that mean? It's defined to be 180 divided by pi in degrees. And actually, let me pull out the calculator for a second to show you what one other thing I was talking what I'm here. If I do 180 divided by pi in my calculator, that's what 1 radian means. And I think this is really useful because what I'm getting at here is I'm trying to there's an understanding of what radians means and what does degrees mean. But fundamentally, 1 radian is equal to 57.3 degrees. I can see here. So it gives me kind of a sense of, well, 60 degrees, 57 degrees is I kind of having a sense for what that angle means, but in radians, that's what approximately 1 radian is. And actually, if we go back to that GIF that or GIF reference showed prior, we can kind of visualize radians again in a new light and say with the unit circle or with any circle of radius r, notice that a radian is exactly 57 degrees. So if I'm visualizing that, I can kind of see that there. And if I go around the circle 2 or 3 radians, we're not quite all the way around because it was a little less than 60 degrees. So 3 of them is a little less than 180. So the remaining part, pi radians, is a little bit past 3 radians. 3 radians doesn't quite get you halfway. But pi, that's the amount that gets you exactly halfway around the circle. And that's, again, the importance of pi in geometry. And I'm sure there's some pi jokes here about how circles and pies, related. Wondering, well, is that why we call it pi? Um, I don't know for sure. But anyways, coming back to the lecture, my remaining point here is that if I want to convert between radians and degrees, we can use these fundamental connections, and these connections um, are important. And actually, one last thing before I move on is why is 360 degrees? Why is that a full circle? But this is another thing that's early man originally approximated the period of the Earth cycle, like how many days per year, to be about 360. They didn't know exactly how long it took to finish, because the Earth cycling around the sun is another periodic phenomenon, which amounts to the amount, like it creates a pattern in the amount of daylight that we get in each day. And early man thought there was a lot of mystery around, well, why are some of the days longer and shorter than others? And that's one of the things they studied. And they thought that that period was about 360. And it's interesting that that number has lasted for so long, because as we know today, it's 365. Well, it's actually not 365. It's not a precise number either, and we have daylight, like, or we have leap year and whatnot to compensate for three proper period. But my point, and also kind of remembering this, notice that 2 pi is the period of the unit circle. It's one, whereas 360 is the approximated period of the Earth, and that's kind of the interesting connection there, which makes it kind of hard to forget. Also, another reason 360 is kind of stuck around, like if you've ever wondered, well, why isn't it just 100 degrees? 100 is a nice number. Let's just have a full circle be equal to 100. That way, a quarter of the way is 25 degrees. It's kind of easier. But 360 is actually a nice number because it's really nicely divisible. It's divisible by 2, 3, 5, 6, 8, I think. But it's divisible by all of those same fractions. And if we go back to the unit circle, notice how additionally, in addition to having the radian measurements there, it also has the corresponding degree measurements for each position. And again, those are really equal because pi over 3 and 60 degrees amount to the same value. One's just in